Kia ora, Year 12 and 13. This is a small question from 2012 Scholarship Calculus exam that we looked at on Friday of this week. So this one has got some implicit differentiation in it and also some trig. The trig in here is really easy if you spot it, but you won't spot it if you are kind of crashing your way through the paper. So it's a good example of where you need to get to a certain point and then just slow yourself down and think about some really simple ideas that are going to help you. So we're going to start with this equation. X to the power of n is tan of ny, and we need to find dy by dx as a function of x. Now this is a function of y, so we're obviously going to have to use implicit differentiation on it. So we're going to start by differentiating both sides with respect to x. So the left hand side goes like this: n x to the power of n minus 1, right, that's just from level 2, and then over here I'm going to differentiate with respect to y and then multiply by dy by dx. So that will give me n sec squared of ny. So that's just the chain rule. So differentiating this with respect to y times dy by dx. If you're not familiar with implicit differentiation, go have a look at the video that I did earlier today, one of the other scholarship calc ones, or go and look in the Delta textbook. It's probably in with the conics material. Okay, so in here, what I've got to do now is get an expression for dy by dx. So we get dy by dx is equal to n x to the n minus 1 over n sec squared ny. So we're almost there, but we have to get this in terms of x, not in terms of y. So there are two ways to go here. One of them is to try and do something to turn this sec squared into a tan, and the other is to explicitly work out what sec is in terms of x. So I'm going to go through both of these on two more slides. Okay, so we've got x to the power of n is equal to tan of ny, but my derivative is this. I've got dy by dx is equal to nx to the n minus 1. Whoops, what's happened there? Over n sec squared ny. If we think back to the first trig identity that we learn in level 2 or 3, it's this one here, the Pythagoras identity. And there are two other versions of it. One of them links tan and sec. So I always just derive this to check I haven't mucked it up, but you probably know it. And it's this one here. No room. That gives me tan squared x plus 1 is equal to sec squared x. Right? Hugely useful in all kinds of weird situations. So we're going to use that, and we're going to substitute tan squared of ny plus 1 in here. So that gives me n x to the n minus 1 over n times 1 plus tan ny squared. Now I'm writing it like that on purpose. That gives me this over n times 1 plus x to the power of n squared, which is x to the power of n minus 1 over 1 plus x to the 2n. And that's it, we're done. We've got everything in terms of x. But there's another really cool way to do it if you don't use the Pythagoras identity in this form, and that's to go all the way back to here and basically use SOHCAHTOA and a bit of Pythagoras. So I'm going to do that on the next slide, because you never know when that's going to come in useful. Okay, so let's start by looking at where we started. We've got tan of an angle, tan of ny, is equal to x to the power of n. But we know from SOHCAHTOA that tan is equal to the opposite over the adjacent. So we can put in a 1 here, and now we can draw a triangle. So there's a lovely right angle triangle. There's angle ny, and the opposite side here is x to the power of n. Right, the adjacent side is 1. And that means by Pythagoras that the hypotenuse must be 1 plus 1 squared plus x to the power of n squared, which is root 1 plus x to the 2n. Now that should look really familiar. So we can write that on here. from that we can get the value of sec ny directly. So sec ny is equal to the hypotenuse over the adjacent, which is, let's see, going slowly, 1 over root 1 plus x to the 2n. So now working that back into my problem, we're going to get the same answer. So let's have a look at what we do. We've got dy by dx is equal to nx to the n minus 1 over n, and then sec squared of ny will be that sec squared, which is equal to x to the n minus 1 over 1 plus x to the 2n. Alright, thanks for watching. I'll do some more later on. I've got 73 report comments left to write, and this is turning out to be a great way to procrastinate.